In my last video, I talked about electronegativity, which is basically the tendency of one atom in a chemical bond to take more than its fair share of electrons from the chemical bond. That gives it a partial negative character, because those electrons themselves are negative. That means the other atom now has a partial positive character. This difference in character means that this bond is now considered a polar bond. Now think where else you've heard the word polar before. You might think of the polar regions on Earth or the different ends of a magnet. Basically, all polar means is that there's two opposite sides. So on the Earth, the North and the South Pole are two opposite sides. On a magnet, you have two different magnetic fields. In a chemical bond, you have a positive end and a negative end. That makes this bond polar. Now, when you have a molecule that has polar bonds in it, you'd start to consider that molecule polar, like this water molecule, which has an oxygen bound to two hydrogens, which means there's two polar bonds. These two polar bonds add up together to make one net dipole, which is just the addition of the two polar bonds. That makes this molecule polar. Now we can contrast that with a nonpolar molecule. Let's use a fat molecule, for instance. So this fat molecule has carbons bound to carbons, and since they're the same atom, they have the same electronegativity. So these bonds are by definition not polar. Carbon also has a similar electronegativity to hydrogen, so these bonds are also not polar. So when you make a full molecule made out of these nonpolar bonds, you'd consider this molecule nonpolar. Now this is more than just chalkboard talk. This has ramifications for how these molecules interact with each other. Nonpolar things don't like to interact with polar things. Have you ever been to a restaurant and seen an oil and vinegar container where the oil separates from the vinegar? That's because the oil is fat-based, which is a nonpolar molecule, and the vinegar is water-based, which is a really polar molecule. They don't like to interact with each other, and so they separate in a container. Now that's the basics of polarity. There are a few other nitty-gritty topics that I want to talk about in the next video, like how you can quickly identify whether any molecule is polar or not, but until then, thanks for joining me.